Welcome back. This is the second lesson recording for IM2, January 4th, 2021. The class then went on to doing some independent practice. I'm giving you 15 problems. I would like you to try to complete them as fast as you can. Okay, so these are the first five, then the next five problems. So pause the video and solve these problems, and then finally the last five problems. These are PADEC exercises that I am asking you to enter your answers in on the PADEC slides. Okay, then we went on to just reflecting on how confident do you feel. Okay, so when a is equal to 1, factoring quadratics when a is equal to 1 is the simplest form. So you get to learn the key concepts here. And I want you to move this bar, the pink bar here, to where you feel how confident you are. I feel pretty confident. I need more practice, but I'll get there, or I am lost. I need help. Okay, so please move that so that I can see how you feel. All right, then let's get on to the new lesson material. So factoring quadratic expression by grouping. This is a new method. Remember, quadratic expression is a polynomial that can be written as ax squared plus bx plus c, where a, b, and c are just some number. Okay, it can be positive, it can be negative, it can be decimals, it can be fractions, but it has to be real numbers, except a cannot be 0. Okay, that is one condition. There has to be, for it to be quadratic, that means it has whose highest degree is 2. Okay, so there has to be x squared term. We've learned how to factor when a is equal to 1. When a is equal to 1, like in this case, x squared plus 4x plus 3, there is an invisible 1 in front of the x squared. It's not 0. When there's no number here, it's not 0. The invisible number is actually 1. So it's 1x squared plus 4x plus 3, or a is equal to 1. And we know how to factor this. We are looking for two numbers that multiply to 3 and that add to 4. So that's going to be x plus 1, x plus 3. Now we learned how to factor when a is not equal to 1. So for example, 6x squared plus 17x plus 5. Okay, so there is a number that is not just 1 in front of the x squared. How do I do that? It's a little bit more complicated, and by grouping is the method that I am introducing today. And the 6 is x squared terms coefficient is not 1. So in order to do that, we're going to digress into diamond puzzles that we covered last semester, where you have two numbers a and b, and then top of the diamond or top of the x is a times b, a multiplied by b, and the bottom number is a plus b. So for example, when you had this problem, the top number is 12. Remember, 12 is the multiplication of two numbers, and negative 7 is the bottom number, that is the sum of the two numbers. So I can write, just to help me remember, the top number is going to be multiplication, the bottom number is addition. What are the two numbers that multiply to 12 but add to negative 7? Okay, what are the factors? 1 and 12, if I add those, that's going to give me 13. 2 and 6 is going to give me 8. What about 3 and 4? That's going to give me 7. But I want not positive 7, but negative 7. So they have to be negative 3 and negative 4. Okay? All right, so then a slightly different form that you might see is this. Okay, so again, it's the same pattern. So 40x squared is the multiplication of the two numbers, and negative 6x is the addition of the two numbers. Okay, so the only way you can get x squared is if you have x times x is going to get me x squared. And if I have some x plus some x is going to get me negative 6x. So there is some number here, okay, in front. It's basically the same thing as this, but we just have the variable in there. So I don't want the variable x to throw you off. Actually, I'm going to change that look of the x so that it does not look like multiplication. So the two numbers that I should put in front of the two variable x is, what is the number that multiplies to 40 but add to -6? I just discovered an error there, so I am going to change that to -40. Okay, so it's going to be -40. So I'm looking for a number that multiplies to -40, but that add to -6. Okay, so since it's -40, that means I know that one of the number is going to be positive, one's going to be negative. Okay, one's going to be positive, one's going to be negative. Okay, and what are the factors? If I have 8 and 5, if since the signs are different, then we're looking for difference to be 6. 8 and 5, the difference is 5. What about 4 and 10? That would work. 4 and 10 would work, but we want to end up with a -6. So that means the bigger number between 4 and 10, which is 10, has to be the negative, and that has to be 4. So it's 4x, 4 times negative 4x times -10x is -40x, and then 4x plus -10x is -6x. So this would work. Okay, now it's your turn now. Please um, find what the question mark is equal to for A and what is the question mark is equal to. And this is a pad deck exercise, so for you to enter your answers. Pause the video now. And here are the answers being revealed. Okay, for the first one, it should be -5x and -11x, and then 6x and -5x, -2 and 14, and -7 and -8. When you see an x squared and x here, um, it's up to you. You can just omit the x squares knowing that you are going to have to deal with the x's, or you can put the x squared there. um, that's fine too. But you should be comfortable with both or how. Okay, then let's finally get into factoring quadratics by grouping. So if you have 3x squared plus 10x plus 8, we cannot use the traditional method because of the 3. The leading coefficient or the number in front of the x squared term is 3. So we cannot use the method that we've been using up to now. So the first step is to set up the diamond and solve it. Okay, setting up the diamond is tricky. Well, it's not tricky. You just need to know how to do it. Okay, so you get 24 from finding the coefficient of the x squared term and the constant 3 and positive 8. You're multiplying 3 times positive 8 and you get 24 here. And then the middle term, the coefficient of the middle term, which is 10x, is 10, comes down here. So first thing you need to do is draw your x. And for the top, you need to multiply the coefficient of the x squared and the constant and get that top term. And the bottom term is the middle coefficient, the coefficient of the x term. Okay. And then you know how to solve it. Okay, so from here, I'm looking for the product to be 24, but the sum to be 10. It has to be 4 and 6. So then I am basically splitting the middle term 10x as 6x and 4x. That's rewriting the quadratic expression by splitting the middle term into the solution from the diamond. So that becomes 4 comes here from the solution that you got, 4x here, and then 6 comes there. Okay, notice that this 10x is just being split up as plus 6x plus 4x. So this expression is exactly the same as this expression in value. It's just the middle term is split up. That's what we're trying to do. And why are we doing that? So that we can split the polynomial into two added parentheses. So we are adding the parenthesis 3x squared plus 6x for the first one, and then the second two, 4x plus 8. Once we've done that, step 4 is to find the greatest common factor for each parenthesis. So for the first one, 3x squared plus 6x. Remember, 3x squared just means 3 is being multiplied to x times x, and 6x is 2 times 3 times x. So looking for the GCF of just the first parenthesis, you see that there is 3 and 3 common and x common, so I can take out 3x for the first parenthesis. For the second one, 4x plus 8. What are the GCF, greatest common factor between that? That is, since 4x is 2 times 2 times x and 8 is 2 times 2 times 2, I know that I can take out 4. 4 is common. 2 times 2, which is 4, is common to both. So that just becomes 3x comes to the front here. 3x times what is x squared? What's left is just x here. So that is here. And then for the second term, 6x, 3x times what is 6x? 3x times 2. Or the term that is left behind is the 2 that comes here. For the second parenthesis, 4x plus 8, we said the common factor GCF was 4. Okay, that's the two circled ones. What are we left with? Oops. We're left with x plus 2. And so you've factored out each of the GCF for each of the parentheses, the first parenthesis and the second parenthesis separately. Okay, all right, so then this is what became of it. Then step 6 is find the greatest common factor for each new term. So we've converted this. Now remember, this is 3x is being multiplied to x plus 2, and 4 is being multiplied to x plus 2. Notice that x plus 2 is being multiplied to both the first part, and x plus 2 is being multiplied to second part as well. See, x plus 2 is here, x plus 2 is here. That means it's being multiplied to both. So it is common to both the first half of the expression as well as to the second half of the expression. So this time we're going to take x plus 2 out. Okay, you take the x plus 2 out as the GCF, and then you're left with 3x here and then plus 4. So this is your final answer. Okay, and again, the last step is to use FOIL to check your answer by multiplying out the binomials. So I know that 3x, x times 3x was 3x squared, x times plus 4 is 4x, then 2 times 3x is 6x, and then finally 2 times 4 is 8. Then combining the like term, you are indeed getting the original equation expression. Phew, that took a while. Okay, so these are the summary of the steps. Okay, please pause the video and read this. Then I will go over another problem in the next lesson recording.